Okay, so we're back today talking about 8.1, which is our basic BCA table stoichiometry. So let's look at this first problem. This is from your worksheet. And again, this is like the most basic type of stoichiometry problem we're going to see. So the first thing we need to do is balance our equation. So take a second, make sure your equation is balanced. And this one ends up being 2, 3, 2, 2. It's really important that you have the correct balanced equation to start, because if you're starting with the wrong balanced equation, everything after that is going to be messed up. So if you're writing the equation from words, make sure your compounds are correct, and then make sure your equation is balanced. That is key. So we need to read through the problem and fill in our before line on the BCA table. So hydrogen sulfide gas, that's this guy right here, which smells like rotten eggs. Fun fact. Burns in air. Remember, whenever we see burns in air, we mean reacts with oxygen, because it's oxygen in the air that causes things to burn, to produce sulfur dioxide and water. How many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide? Okay, so that question tells me I'm starting with 8 moles of hydrogen sulfide. It's burning in air, and it doesn't tell us how much oxygen, so we're going to assume that's excess, meaning there's more than enough oxygen to react with all of that hydrogen sulfide. I mean, it's the air. There's plenty of oxygen. So we just write excess, means more than enough. And these are products, which means before the reaction starts, we're always going to have 0 of them, because if there's no reaction, then there can't be a product. So before the reaction, there are no products. So then we go to the change line. So the change here, we use up all of the hydrogen sulfide. So that's what the question tells us. We completely burn 8 moles of hydrogen sulfide. So we're going to subtract out all 8 moles. We need to figure out the rest of these, though. So we're going to use our ratios from the balanced equation. So I have 8 moles of H2S. And I want to figure out how many moles of oxygen I use. So I'm going to put that over X moles of O2. I set that equal on the other side to my ratio. So I know from my balanced equation, there are 2 moles of H2S. So there's 2 H2S for every 3 oxygens. So again, that's just my ratios for my balanced equation. For every 2 hydrogen sulfides, they react with 3 oxygens. And I solve for X. So I cross multiply. That gives me 3 times 8, which is 24, equals 2x, divide both sides by 2, I get 12 moles of oxygen. And you can always do a little self-check. I need more oxygen than I do hydrogen sulfide. 3 is bigger than 2. Therefore, I should use more oxygen than I do hydrogen sulfide. 12 is bigger than 8. So there's all these little built-in checks for you just to make sure that you did your algebra right. So 3 is bigger than 2, 12 is bigger than 8. Check, that looks good. Now we can ratio any 2 things together to get a missing value. Now here I see I have 2 hydrogen sulfides and 2 sulfur dioxides. Those are the same number, 2 to 2, that's a 1-to-1 ratio. So that means it's going to be the same. Notice how I switched to a plus sign over here. Sometimes I'll draw this vertical line here. So these are my reactants. I use them up. These are my products. I make them. So I add products, I use up reactants. And here you see with the sulfur dioxide and the water, it's a 2-to-2 ratio. Or again, another 1-to-1. So these should be the same number. 2 and 2 are the same. 8 and 8 are the same. Same ratio. And that's the hardest line to fill in, is the change line. That's where you use those ratios from the balanced equation. To get your after line, it's just simple subtraction. 8 minus 8 is 0. I used up all of my hydrogen sulfide. Excess minus 12 is still excess. That means if I had a lot to begin with, and I used up a little bit of it, I still have a lot. 0 plus 8 is 8 moles, and 0 plus 8 is 8 moles. So that means at the end, I used up all my hydrogen sulfide, got plenty of oxygen left in the air. I end up with 8 moles of sulfur dioxide and 8 moles of water. So the last thing to do is look at the question. It says, how many moles of oxygen gas would be needed? Well, here's oxygen, and it looks like I use 12 moles of oxygen gas. So the answer to my problem is 12 moles of oxygen gas would be needed. And that is how you do the most basic stoichiometry problems.